lesson is going to be about solving absolute value inequalities. So we are talking about inequalities this time, not equations. That means we're going to have less than or equal to, greater than, and greater than or equal to. So we're going to have those inequality symbols. Now, at the beginning of an inequality expression, you're going to do the same thing as with an equation. You're going to isolate the absolute value expression by using the reverse order of operations. Once you isolate your absolute value, you need to make sure the absolute value expression is on the left of the inequality symbol, because making sure it's on the left is going to make sure that the shading part, once we're actually shading, is correct. So once you have that absolute value on the left of your inequality symbol, you need to determine what type of statement you have. You can have either an and statement or an or statement. If you have less than, that's this symbol right here, or if you have less than or equal to, that's this symbol right here, then you're going to have an and statement. And in an and statement, you shade between the two numbers that you find as part of your inequality, as part of your absolute value inequality. So you're going to find a lower number and a higher number, and you're going to shade in between when you have less than, when you have an and statement. If you have less than or equal to, the only difference is not only are you going to shade in the middle, but you're also going to shade your beginning and last point. With less than, you don't shade the beginning and end point. You keep them open. They're both going to be open, but with less than or equal to, the equal to part makes it closed, so it's going to be closed there. Now, we also write this in something called interval notation. Interval notation basically just states the first value and states the last value. And the way we write that with less than is parentheses, the first value, comma, the second value, close parentheses. With less than or equal to, we're going to have brackets instead of parentheses. The brackets means we're including the numbers. The parentheses means we're not including the numbers. So we would have bracket, the first number, comma, the second number, and then a bracket. So that's the and statement. Now for the or statement, you're going to have greater than, which is this symbol right here, or you're going to have greater than or equal to, which is this symbol right here. And in an or statement, you shade on the outside of the number line. So you're going to have shaded from negative infinity until your first value, and then you're going to skip a section in the middle, and you're going to go to your second value and shade after that until infinity. Now, if you have greater than, your two major values are going to be open. So they're going to be open. But if you have greater than or equal to, they're going to be closed. So same thing with our interval notation. Since we're shading at negative infinity, we're going to start with parentheses negative infinity. Then we're going to go to our first value, a, and we're going to use a parentheses to close it because it's open. Then we're going to have a break right here. This break right here represents this U. That union is that break between A and B. So then we start at B, so we're going to open a parentheses and go to B, and then we go to infinity, so then we put comma, infinity, and close with a parentheses. Now with greater than or equal to, it's exactly the same. The only difference is that in the middle at A and B, we have brackets because these are closed. These are open, so we have parentheses. These are closed, so we have brackets. So remember, less than or equal to is and, greater than or equal to is going to be or. And statement, you shade in the middle. Or statement, you shade on the outside. If you have less than, it's going to be open. If you have greater than, it's going to be open. If you have less than or equal to, it's going to be closed. If you have greater than or equal to, it's going to be closed. Okay? So hopefully this kind of gives you a good introduction as to how you're going to shade your number lines. But we don't really know what this means until we see an example. So let's go to example 1. Okay, so here we have our first two examples. I have the absolute value of x minus 1 is less than 3, and the absolute value of x minus 1 is greater than 3. Now, my absolute value is isolated, so that's good. It's on the left side of the inequality symbol, so that's good as well. So what we want to do next is create two inequalities to go with this. We're going to have x minus 1, and we're going to keep this symbol the same. We're going to say less than 3. And this is less than, so this is an and statement. So we're going to say and x minus 1. And we're going to flip this symbol now. We're going to say greater than negative 3. Now we're going to add 1 to both sides here, getting x is less than 4. And again, we're going to add 1 to both sides here, and we get x is greater than negative 2. So now we're going to draw a number line and mark this on the number line. On one side of the number line, we have negative infinity. On the other side, we have positive infinity. Somewhere in the middle, we have 0. Now, putting this in order, positive 4 is somewhere over here to the right of 0. Negative 2 is somewhere to the left of 0, somewhere right here. Okay? Now, I don't have the or equal to part. I just have less than and greater than. So my points are open. Negative 2 is open, and positive 4 is open. Now this is an and statement. Since this is an and statement, we're going to shade in the middle. So now in interval notation, this is open, so I'll use a parentheses, negative 2 comma 4, and this is open, so we use a parentheses. Over here, we're going to do the same thing, but this is greater than, so this is an or statement. So we're going to say x minus 1 is greater than 3, or x minus 1 is less than negative 3. We're going to add 1 to both sides here and get x is greater than 4, or add 1 to both sides here. We're going to get x is less than negative 2. So now we draw our number line. On one side we have negative infinity, on the other side we have infinity. 0 is somewhere in the middle. Positive 4 is to the right of 0. Negative 2 is to the left of 0. Neither of these have the or equal to part, so both of these are open. Now this is an or statement, so we're going to shade on the outside. Okay? So now for my interval notation, I'm shading beginning at negative infinity, so I'm going to say parentheses negative infinity, comma, and then I shade until I get to negative 2. This is open, so I'm going to use a parentheses. Then I have a break, so I'm going to put union for my break. Then I'm open at 4, so I'm going to use a parentheses, 4, comma, and I shade to infinity. So I'm going to put infinity, close parentheses, and there's the difference between both of my problems. With an and statement, I shade between negative 2 and 4. With an or statement, I shade from negative infinity to negative 2. Then I skip to 4 and shade to infinity. Okay? Now these are open because I don't have the or equal to part. If I had a line underneath these, the or equal to part, they would be shaded in, but they're not. Okay, I have two other examples here. I have the absolute value of 2x minus 3 plus 4 is less than 1, and the absolute value of 2x minus 3 plus 4 is greater than 1. So we're going to see the difference here. Now my absolute value is not isolated, so I need to isolate it. So I'm going to subtract 4 from both sides. This eliminates, and I get the absolute value of 2x minus 3 is less than negative 4. I have a problem here. Absolute value represents a positive number. And this is saying a positive number is less than negative 4. Well, a positive number can't be less than a negative number. So this is a false statement. This is false. So on my number line, when I try to shade negative infinity to infinity with 0 somewhere in the middle, I don't have any solution that would work. So my number line is going to be blank. So my interval notation here is going to be the empty set. So I have no solution. Let's try the other one. Subtracting 4 from both sides gives me the absolute value of 2x minus 3 is greater than negative 3. Oh, I made a mistake over here. This should have been negative 3, not negative 4. I apologize for that. But it's still the same thing. A negative number would make it false and it would be no solution. Now over here, the absolute value of 2x minus 3 is greater than negative 3. This is a positive number and it's greater than a negative number. Well, that's true. A positive number is always going to be greater than a negative number. So this is always true. So on our number line, going from negative infinity to infinity with 0 somewhere in the middle, if it's always true, it's true everywhere. So we would shade everything. So that means for interval notation, I'm starting at negative infinity and I'm going all the way to positive infinity. In other words, my solution is all real numbers. Another way of saying all real numbers is parentheses, negative infinity, comma, infinity, close parentheses. This is the same as all real numbers. These two are the same. Just like the empty set is no solution. So these are our two examples here. Okay, so in this example I have 3 times the absolute value of 4x minus 5 minus 16 is greater than or equal to 5. So I need to isolate my absolute value. So I'm going to add 16 to both sides here, eliminating this. So I get 3 times the absolute value of 4x minus 5 is greater than or equal to 21. I'm going to divide by 3 on both sides, eliminating the 3. And I get the absolute value of 4x minus 5 is greater than or equal to 7. So now I need to make 2 inequalities. 4x minus 5 is greater than or equal to 7, and this is greater. So this is an OR statement. 4x minus 5 is less than or equal. We flip it, and then we change the sign to a negative 7. Okay, so now we solve. Adding 5 to both sides here, I get 4x is greater than or equal to 12. If we divide by 4, this reduces, and x is greater than or equal to 3. Over here, adding 5 to both sides, this reduces, and 4x is less than or equal to negative 2. Dividing by 4 on both sides here reduces that, and we get x is less than or equal to negative 1/2. Negative 2 over 4 reduces to a negative 1/2. So now we can put this on a number line, and remember, this is an OR statement. So on the number line, going from negative infinity to infinity with 0 somewhere in the middle. This is a positive number, so that's going to be to the right of 0. So 3 is somewhere to the right. Negative 1/2 is somewhere to the left. This is or equal to. It's got the equal to symbol. This is greater than or equal to. This is less than or equal to. So my points are going to be closed. So this time, these are not open. We're going to bubble these in. Now this is an or statement, so we're going to shade on the outside. So now for interval notation, we start at negative infinity, comma, negative 1/2, close parentheses. We have a break, so we have a union. Now we're starting at 3. Oops, I made a mistake here. This is closed, so this should be a bracket. If it's closed, you use a bracket. This is closed, so I'm going to use a bracket. We're going to put 3, comma, and then we shade to infinity. So we're going to put infinity, and then we put a parentheses. By the way, infinity always has parentheses. Okay, infinity is always open. So with infinity, you're going to put a parentheses. With numbers, you have to check. Does it have the or equal to part or does it not? If it has the or equal to part, it's going to be closed. If it doesn't, then it's going to be open. If it's open, you use parentheses. If it's closed, you use brackets. Okay, well, I hope you enjoyed today's lesson on solving absolute value inequalities. That was a lot of information. So if you have any trouble, please make sure you send me a message in Schoology, or you can send me a text. Have a great day, everyone.